Assalamualaikum. My name is Sama and my roll number is 21TE09. Lab 5 of Digital Signals Processing. Representation of discrete times digital signals in frequency domain. The objective of this lab is to representation of discrete time digital signals in frequency domain. Second is resolution of spectrum. Third is computation of magnitude, phase and power spectrum. And the fourth one is spectrum leaking and avoiding spectrum leaking. Task 1. In the input, in the input of this task, in which we calculate the discrete Fourier transforms. Discrete Fourier transforms can be calculated by using the different formulas, but we use this formula here you can see in the output. And second is inverse discrete Fourier transform by using these formulas here you can see in the input of this task. And the second formula of this inverse discrete Fourier transforms, we using this by a formula here you can see in the input, in which we make our own functions by discrete Fourier transforms and using it inverse formulas. Here you can see this. Now you can see the output of this task 1, in which we calculate the discrete Fourier transform by using these two formulas, and discrete Fourier transform and inverse discrete Fourier transform. In task 2, here you can see the input of this task 2, in which we are doing frequency resolution can be enhanced by adding trailing zeros, and in which we calculate digital Fourier transform as you can see in the task 1, and we also calculate the signals and observe the changing in the frequency spectrum, and we use different spectrum by calculating the discrete Fourier transform in task 2. Here you can see the input of this task 2. We are calculating discrete Fourier transform and by following signals and observe these changing in frequency spectrum. Here you can see the output of this task 2, in which we are calculating frequency resolutions by adding trailing zeros. Task 3. The input, you can see the input of this task 3, in which we are doing built-in functions of by using MATLAB. That we have an arbitrary signals x is equal to 1, 2, 3 and 4, and then we calculation of discrete Fourier transforms, and another is extraction. We are using extraction of real part of frequencies and real part of frequency spectrums, and in the end we are doing inverse discrete Fourier transform to time domain representations, and you can see the output of this task 3. Task 4. In task 4 we are calculate discrete Fourier transforms, and in which we are plot magnitude spectrums, space phase spectrums, power spectrums for signals in, and also we observe the effect of zeros paddings. And now you can see the output of this task 4, in which we are calculating magnitude spectrums, phase spectrums and power spectrums